Hey guys, today I'm going to talk to you about math. You know, this ain't no math, just 1 plus 1 or 2 plus 2. This is calculus math. Stuff from the movie Stand and Deliver. Now don't get scared, it's quite simple really. So say you're in math class, obviously spacing out probably, but the teacher decides to give you a final project in which you need to do a sketch of a graph for a given equation, right? Now at first you think, oh, it's just simple, I just copy from the smart guy or just, get a graphing calculator and plug in random numbers to generate a graph. However, if you're like me, don't have a graphing calculator or a calculator at all besides your phone, we're going to need to use it, our pen and our brain cells that we have. So let's begin. Say he gives you this equation. Find intervals where concave up or concave down for the following equation. F of x equals x cubed minus 3x squared plus 5x minus 4. At first, you're probably thinking, what the hell? I don't have a graphing calculator, I've got nothing. So let's use those brain cells, if there are any left. So we can easily just tell this is not a quadratic function. If it was a quadratic function, that x cubed would not be there. But it is. So we know it's not going to be like this or like this. Instead, this type of graph will look something like this. Sort of like an S shape. So before I proceed any further, I just like to say any key terms that I use or any laws that I would use will just be in the information bar below so you can reference to it. So first of all, I just like to say, let's start off by taking the derivative. And it's quite simple really, once you get the hang of it. But first, let's just take it. F prime of x equals 3x squared minus 6x. Now that's the derivative. Oh wait, there's something else more. Plus 5. Sorry. Anywho, now the derivative is often used to find critical points and to determine whether an equation is increasing or decreasing at certain intervals. Well, that's not what we're looking for. We're looking for concavity, of either up or down. So, in order to do that, we're going to need to take a second derivative. Yes, there's such a thing called a second derivative. Now let's do that instead. F double prime of x equals 6x minus 6. That, ladies and gentlemen, is simple. That is not. So now you can stop worrying about what you're going to do and where the smart person is at to copy, because now you're going to be the smart person. So in order to find any inflection points, and before I say anything else, an inflection point is a point on the graph where it changes from being concave up to concave down or vice versa, which is going to be very helpful because that's what we're looking for. So all we have to do is just set this equals 0 and solve. So we have 0 equals 6x minus 6. All we do is add 6 to both sides. You end up with 6 equals 6x. Then you divide by 6 and you get 1 equals x. Of all the numbers to use in the world, this is quite simple. It's 1. So in order to find the point on the graph, we're going to need to plot, well not plot, but insert this number into the value of x. So let's do that. F of 1 equals 1 cubed minus 3 times 1 squared plus 5 times 1 minus 4. That would give you 1 minus 3 plus 5 minus 4, which gives you negative 2 plus 5, and that gives you 3 minus 4, and that gives you negative 1 as your y value. So your inflection point will be at 1 and negative 1. So now that we have that, we will also use the second derivative to find out our concavity. So in order to do that, we will have to get an x value to the left and to the right of 1. So let's just pick easy numbers. 0 and 2. Easy, right? So now all we have to do is plug in these two numbers into that equation. Now, something is concave up if what our result is positive and greater than 0. Something is concave down, however, if it's less than 0. So let's start with 0 first. We go 6 times 0 minus 6 equals f prime of x. So we obviously know it's negative 6. And we also know, if we are awake and alive, that negative 6 is less than 0, which means that anything to the left will be of 1, which is the inflection point, will be concave down. We have that done. Now let's use 2 instead. So f double prime of x equals 6 to 2 minus 6. We have 12 minus 6, and that gives us with 6. And 6 is greater than 0. And that means that anything to the right of 1 will be concave up. Ladies and gentlemen, you have your answer. Anything to the left of 1 will be concave down, while anything to the right of 1 will be concave up. So basically, our graph will look something like this. That's it. You're done. Guess what? Now you're the smart person. So go show off to the rest of the world.